Please spend a few minutes on your do now, and when you're done with that, you may continue with the video. All right, guided notes on our square root functions and inequalities. Functions, so we know that when we plug in an x, we get out a y, right, in an fx. Inequalities, of course, remember that greater than or less than, greater than is the first one there, the less than. Of course, the or equal to's, and we'll take a look at what those might look like on a graph as well. So hopefully by the end of this video, our goal is for you to be able to graph and analyze your square root functions and inequalities. If a function contains a square root of a variable, right, if the variable is inside the square root, it's called a square root function, right? Not too interesting of a name, or not too surprising of a name, I guess, right? Square root function. The square root function is actually a type of radical function, and we're going to spend some more time tomorrow and throughout the week about what other types of radicals might be. Your parent function is right here. I do want to make sure that this is drawn as a little arrow on your graph. Of course, it goes through 1, 1, should start at 0, 0. The square root of 0 is 0. The square root of 1 is 1. And then the next one I usually jump to is the square root of 4, right, which is 2. Then I would jump to square root of 9 is the next one up to 3 and so on. That's how I tend to plot points for my parent graph. The parent function is known as y or f of x, right, either one is fine, is the square root of x, right, and that's how I need to plug in square root of 0, square root of 1, square root of 4, to get those x coordinates here, right, the x coordinates here, and I get out my y coordinates on this other side, right, I get out my y coordinates on this other side. That's how I know how to plot my ordered pairs. The domain of your square root function then, notice you can't plug in any negative, right? What is not defined is going to be where x is less than 0. You can't plug anything negative under a square root to get a real number out. Last trimester we learned that imaginary numbers exist, but they don't get graphed on my coordinate system. So my domain is actually starting with 0. I can take the square root of 0, that's okay, and it goes up to infinity. This is my interval notation. Of course, that's going to look like this, x such that x is greater than or equal to 0. If you prefer set builder notation, either is fine, right? So again, this first one is interval notation, just in case I ask you later. And this is set builder, right? I build a set, right? A set meaning those braces. The range, notice, is actually the same thing, right? From 0 to infinity. Right, because my y's start at 0 and then go upward, right? My graph actually keeps going indefinitely in this direction, right? Continuing right and up the whole time. Notice, remember, if I do the range, I call out my y's. That's the only difference here. My intercepts, I only have one. It's actually the origin is at 0, 0. And then my end behavior, notice I want to describe the extreme values of x. So I would typically say, right, when we're going to talk about y can't here now, as x goes to negative infinity, what happens to y? And as x goes to positive infinity, what happens to y? This is typically what I would discuss for my end behavior. Notice if you're looking on the graph as x goes to the left, the function doesn't actually approach negative infinity. Right? Like this isn't a thing. I can't approach negative infinity. The smallest it approaches, we just defined actually in my domain, is actually 0. So as x goes to 0, y is actually going to 0. It really is exactly the ordered pair 0, 0. Right? But as x goes to infinity, that is interesting. As I go to the right, my function, even though it's slow, continues to go in an upward direction. So my function goes to infinity. So that's going to be my end behavior for this as well. So identify domain and range of the function. The domain, this first example I have a little description of how I'm doing it. The domain only includes values for with the radicand, right, the number underneath the radical, is non-negative. So when I find the domain, I grab whatever's under the square root symbol and I say, let's make sure that is not negative, which means it's positive or 0. Right, it's positive or 0. I'm going to move that right over here. And then I solve, so I'm going to subtract 4 from both sides. I moved it over here because that's really simple now to write in set builder notation, right? Of course, if you prefer, you can say the smallest is -4, and then it just keeps going, right? So either way is fine to write that domain. And if you recall, it was the extreme value, the extreme smallest value, one would say here, of x that gave you my extreme value of y, my smallest value of y. I'm going to do the same idea here. This -4, right, which comes from the domain, right, it comes from right here in the domain, that's the number I'm going to plug in actually into the function again and says, what happens whenever I plug in -4? Right, that's going to be what I would like to call the extreme value. It's either going to be the biggest or the smallest, depending on the function, right? Well, the square root of 0 is 0. That's the absolute extreme value it is. Since I'm not doing anything else fancy to this, this is actually just going to shift the graph. We'll talk in a moment. So the range is actually going to be y such that y is greater than or equal to 0, right? Or, of course, 0 to infinity for that range, right? So either way you want to write that, that's just fine. Notice we're going to do a similar thing up here, the domain and range. So again, I grab whatever's under the square root. I say, well, if that was negative, it would be imaginary. So I write it as not negative or greater than or equal to 0 and solve. Right? Of course, I can easily put that into set builder. I would just put x such that in front of it. Put it in braces. Or, of course, you could say from 3 to infinity. Right, that's going to be your domain. Right, this is my domain right here. My range, on the other hand, right, to find my range, I use that 3. Ooh, excuse me, why does this say -3? Good question, Miss Mickle, that's wrong. Thanks. Oops. That's fine. My apologies. I'm going to use this same 3 and plug it into my function. All right, so if I take the square root of 3 minus 3, I get 0. We're going to find that a lot, actually. It's going to be the 0. Again, because it comes from this original range way up here. Right? So my range is going to be the same in this case. Now, let's take a look at a little more interesting one. Notice this one has a lot of pluses and minuses. I still grab what's under the square root. Right? I say whatever's under the square root has to be greater than or equal to 0. It cannot be negative to give me a real number. So there's my domain, right? I write it in set builder really quickly. To find my range, I still use that number. Now notice what happens if I say f of -6, right? I get the square root of -6 plus 6 and then plus 2. Square root of 0 plus 2, I end up with 0 plus 2, I end up with 2. 2 is the extreme value, and unless otherwise noted, which we're going to talk about here in a few minutes, that's going to be the minimum. So I would say this is y such that y is greater than or equal to 2. Again, I found that by plugging in my restriction from my domain into the function and found that y coordinate.